My name is Paul Pena, and today we'll be talking about momentum. Now, momentum is a product of mass times velocity, represented by the letter P, where mass is measured in kilograms and velocity is measured in meters per second. Now, impulse is a force given on an object in a short amount of time, where time is called collision time. And we can calculate impulse using any of these three equations: force times collision time, change in momentum, mass times final velocity vector minus mass times initial velocity vector. Momentum and impulse are vector quantities, not scalar, and scalar are things that only have magnitude, like time and mass, length. They're more like vector quantities. Vector is I don't know, I had to look it up. So it's a quantity having direction as well as magnitude, especially in determining the position of one point in space relative to another. So we can think of vectors as an arrow pointing in the direction of our motion. We can use a graph to point our arrows in any direction of our motion. For example, we'll show here how we can derive some momentum. Notice how this is the distance I have traveled, and that'll help me calculate my velocity. And my origin is at xi, and I traveled all the way to xf, and we can calculate that using the delta x equation. Notice how I place my start of origin at 0 and my final all the way at negative 70 meters. So that way I can represent it as a vector. We can think of it as a vector because it has direction and magnitude, just as well as momentum. Now, momentum is a vector because it has velocity and it's going in the negative x direction. So therefore we can have a momentum vector. Notice when my velocity increased, so does my momentum. So what is my momentum when I have a velocity of 5 meters per second and a mass of 60 kilograms? According to the equation, momentum equals mass times velocity. So if we plug in 60 kilograms for mass and 5 meters for velocity, we get 300 kilograms per meter second times meter second. Well, conservation of momentum states that if we have an initial momentum must equal our final momentum. Then we should also equate that initial impulse should equal final impulse. In here we have a demonstration of me kicking a ball, and we'll play that back again. Notice how my foot is about to exert or hit the ball, and the mass of my leg and its velocity is going to transfer that momentum to the ball. Notice my ball's momentum is at 0, and once it gets hit, its momentum increases because stating that conservation of law, it transferred to the ball. Quick question: what's my impulse if the force exerted on the ball is 14 newtons and my collision time is 0.04 seconds? Well, according to the equation, impulse equals force average times collision time. If we plug in our numbers for force and time, we get 0.56 newtons times seconds, which are the units for impulse. We can think of momentum and impulse as you see me juggling here. The ball's momentum is constantly changing due to the force on my foot. The momentum on my foot is causing the ball to change the other direction. We can also see it this way. Notice how the ball hits the floor and bounces up, and my foot catches it. Notice how the ground gives an impulsive force to the ball, to the type of material on the ball as well, makes the ball bounce back up. And notice how my foot slows the impact or increases the collision time, lessening the force of the impulsive force on the floor down to barely anything. Well, I hope y'all learned something about momentum and impulse, and hope y'all liked it. Bye.